Start streaming. Good morning, people who want to see the stream. I will just pop myself into the bottom corner because I'm talking about this, and on Discord I'm doing voiceover because we have more people than Discord will allow me to video stream to. So it seems to still lock people in the video stream if I turn my video on, but it allows you to come in while I'm screen sharing. So what we have here is I've been talking about giving the networking lecture, right? So multiplayer gaming. And as part of that, I have previously created a Godot game that is a multiplayer networking game. But the multiplayer part of it is that if we have a look, we have the start screen here. And I have among my assets, I have levels, and these levels, way over there, among the levels we have the main level, which is actually a game, and we have the slides level. So if I go to the slides level and load that up, what that says is that there is and if I get this right, you'll see that there is a follow game and a big window which has which is the slide rectangle. Now that slide rectangle is just a big texture, right? So it's just got a texture, currently empty. But when I load my slides, I load the slides from the dark slides under the assets, under images, I have slides, and I have dark slides, and we have all of the actual dark slides. Now those are just PNG images which are loaded into this window frame, right? So this is just using the game engine to do to grab PNGs, put them on screen as a texture. When I update with my arrow saying which slide I'm on, I send an instruction to everybody else, move slide. If you are following me, then you change slides with me. If you've gone ahead or behind me, you ignore my instruction to change to a new slide because you're not on the same slide as me, right? So there's this approach where I'm allowing people to look around the lecture while also being able to come back and follow me in the lecture because I'm using that multiplayer system. Now the question came in from one of the students here, is I'm having problems because I'm on Linux, and here I would go to export and you bring up currently I'm using the Windows preset, and I can export all, or I can export project. Now I could add a Linux exportable. I could export that as runnable, and I'm assuming you're on an x86 architecture, Sarah? So if you're on an x86 64, yep, then I should be able to export the project, and I will call it, so export we did debugging, and I will create a new folder called Linux, and then go OK, and we'll save it. Now, at the moment, it is going to create, it's creating the executable and the data pack rather than building it all into a single installable. That comes with the export all. I can actually build a single executable, but at the moment, the first time you run it, it's easier if you just export the project, and then I can, because and so the game engine has the ability to export to different tools. I can jump in and go to here, and you can see that I'm in the easy peasy and I have Linux. And so this would be the SO files for Linux. Oh, so I was hoping to no. So one thing I can do is turn that into a zip for you, and so go compress to zip file. Do you want zip or do you want something else? So the idea is that you can press that to a zip file, and then I can take that zip file, and if I'm very clever, I could try dumping it into the. Is it going to be too big for 28 meg? It's not huge. There you go. That's the Linux zip. So Sarah, you can try that. And so okay, so the reason why I'm doing it is not just because, hey, Sarah would like his Linux, it's because I'm trying to show you one of the features of Godot is exporting a project. Now, if I want to export all, then I can decide what mode I want to release in. And so here I can say release and release. So release versus debug. With debug, you get the messaging in the system that shows you where the errors are occurring. With exporting for all and saying I want to release export, then that gives me a single executable which should run without those additional packaging files. But one of the nice things of you seeing the zip file and seeing the packaging files, you can kind of see what's going on more rather than having it hidden as a single executable. But the idea is part of the reason you use a game engine is because you want to be able to do things like build for Windows, build for Linux. So currently Sarah is downloading and hopefully unzipping and may even be able to run it. I have not tried the Linux version, so that is just completely new. Okay, so without further ado, shall we get on to talking about multiplaying? Now, at the moment, you're all following me, and hopefully those online and on. I'll just check that my audio is working on my Discord. It does appear to be on my OBS, so it does appear to be streaming correctly. Right, you should be, well, there were 7 of you suddenly. Someone rushed ahead. So, there are 5 of you on game slide 2 already. Okay, or rather 5 of you have joined me here. So, today's lecture, I was going to talk, so basically I'm going to talk about multiplayer because it's working. Otherwise, I was going to talk about groups and the 6 animal model more deeply. But we'll start talking about some multiplayer, seeing I'm here, I've got it working on this machine. Technically, how this is working is that I have at my home here in New Zealand, I have a static IP address, and so what I've done is I'm paying an extra $10 a month so that I can have static IP address, and what that means is that I have an IP address which I put in as a fixed IP address for this lecture, right? So I'm the only one who can actually host this at the moment. If you guys try and host, it'll go, hey, no. And, I set it as a fixed IP address so you guys wouldn't have to be typing in IP, I wouldn't have to be typing in IP, we wouldn't be getting it wrong. It would you'd just join, and that's basically me being the server. I could have written a separate program where I was the only one who knew how to host, but we set it up in that basic way. What the static IP address allows me to do is that on my network, I have, so this is my network. What I'm doing is under my advanced, I have where did it go? Advanced setup, port forwarding. So on my network, I have a bunch of machines. As you can see here, I've set up Minecraft, and I've given it a port for my son to be playing Minecraft on his machine, which is 1.5. And down here, you can see I've set up the Easy Multiplayer as external port 7000, and it's the input 10,000, and it's to this 19. Yay, Sarah, it worked. So this is, you are hitting my IP address with port 7000. It is then saying, oh, this is port 7000 coming to my external IP address. And if I do a my IP, you can see my external IP. I could also get it by doing ipconfig, but if you look up what is my IP, you can see that it's checking my IP4, and I am 103.224.130.189, right? So that is my globally accessible IP address. You are accessing that address with port 7000 to get to come in through my router. And which one of these is it? Nope. Okay. Yeah, to come in through my router, which then sends you right. Okay. Sorry, Sarah, that it wasn't made perfectly for you. I should yeah, it's virus detection because I haven't done any work to validate that it's not a virus. So I haven't paid anybody to tell me it's not a virus. But so we're going to go through how that all works in this lecture. You're going to follow me along this path, and we're going to talk about why do we do multiplayer. And you guys can follow me there, or you can be following me in Discord and listening to me. I don't have any audio in the game, right? So the game isn't recording microphone, sending microphone, playing out through yours. All the audio is through Discord. So you might be able to disable Microsoft Defender to download it. I am not sure. You might even be able to agree in one of the sub menus. More info. Yeah, the more info and run is the hey, even if it's not approved, then you can go for it. Yeah. Which is what you might have to do when you're sharing each other's games with each other, is that this kind of, hey, it's not certified, I haven't gone through, because if you're going to create an installer and you're going to get your games certified, then you need to use someone like Sectigo. There are various signing authorities that you can sign up for. So people like Sectigo provide you a domain verification, and you can use the verification codes that they give in your when creating the export for your game, and that will then verify that you are who you say you are, which means then Windows will go, oh, you're a trusted developer because you've paid a signing authority to hold the public key that's verified to you. So when you use your private key to encrypt your installer, that we can guarantee that this program has come from the named company that has paid Sectigo to verify itself. Okay, so you can get around that, but you do have to pay for a signing authority. There are some self-signing things you can do, but again, some of that isn't fully recognized by all systems, and sometimes they'll they'll still make you do what you did there, which is approve. The networking game, we'll get to that later. So there is a back to game where I can slip over to the game. It should be going back to menu, but if you go back to game, you can see I'm now in a multiplayer game, and that actually you would have to go to eNet. I would have to host and do it that way. I think if I'm back here, have I broken it for everybody? That's not the host anymore. So follow host. Where is host? Who is host? No. I might have I might have broken it. Well, it doesn't actually know your name, Sarah. It just it uses the username of the person logged in currently. So that's actually just an easy system lookup. Okay, I appear to, if I close that one, do I have the unhappy one? Where is it? Let's see if I, hello, go back to game, and if I, okay, so, okay, that's not great. Just a sec, I'll go here. Where are you? You're there. Let's see what happens when I go host lecture on this one, and see if I can pick you up. Is anybody able to follow me again now? It's a wee bit buggy. It's not perfect. It's code. So if you can't follow me and you're going back to lectures and it goes weird, then jump back into restart the program and start following me again. Okay, but you're on Discord, so you can follow me there. Okay, so what we're going to talk about is why do we do multiplayer? So hopefully we can. We've got a few of you back in. One of the great things about multiplayer is it creates intentional, sort of automatic balancing, because it means you have an opponent, a human being, and you can then use the human beings to manage the connections rather than the challenge, rather than having to code all of the difficulty yourself, right? So that can really improve the quality of the opponents in your game by having real humans. Now that does, a worthy opponent, you have interesting program and problems. With multiplayer, you have status, which again, beating the machine is not necessarily as much fun as beating a human. You create these shared experience, and you can be sort of part of a winning team in the cooperation. And so when you're doing cooperative multiplayer, you get more than just the beating the puzzle. You get those social aspects that are very motivating. You also can create meeting spaces. You have it's sort of an exploring and understanding the world, and you put some social pressure on the player. Now I see, are people able to follow me, or have I broken the following and we should restart? Worked for me. Okay. So types of multiplayer. There's local on the same screen. There's remote client server, and peer-to-peer. So sometimes people build multiplayer they sometimes call this couch multiplayer, where it's multiple people sitting on a couch playing on a single screen. This is the standard Mario Kart scenario. I have controllers and we're sitting around and we're playing in my home. Or you do these remote sessions. Now we're doing a remote multiplayer where the game at the moment is on the screen. There's actually another game where you can connect using eNet, and you put in an eNet address, and you can host and play games, and so we'll do that later. But this is that client server or straight peer-to-peer. This currently is a client server mode. I'm the client, I'm the server, and you guys are all clients. We have synchronous, which is happening immediately, versus asynchronous. So chess by email was asynchronous multiplayer gaming. And that would be, I'd make a move and send it to you, and then the game would update, and then you would make a move. And there could be a week between moves, right? So there had been some interesting variants. Okay, someone's got their audio on. Okay, they've turned their audio off. That's great. And you can have cooperative shared goals or competitive opposing goals, right? And you can also look at what are team games where you have opponents, but you also have colleagues. Now, here we go. So communities. One of the benefits of multiplayer is that because you are connecting to human beings, you have a whole bunch of membership influence that the community helps you with that game, right? So when there are other humans there, you feel like you're connecting to something, right? And so you have this, and there's a way of influencing other people, and they're more likely to come and play your game because their friends are playing the game, right? You also can, having your community meet social needs for people and create shared emotional connections. If multiple people are playing the same game and they have that shared experiences, they are more likely to talk to each other about it and talk to other people, share it at school, and you get these longer periods of contagion, longer periods where the game is spreading because people are talking about it and they're playing together. And you generally get more hours of play. Now, that can be a problem once you start building addictions around or social pressure to play the game because of the network, or you get horrendous Discord communities. But if you manage it, then you can build your community around your multiplayer games much more easier than you can around a single player game. And you're seeing that in the current mode of games moving to being multiplayer first or multiplayer only, and really only doing their single campaigns as an afterthought, because they want everything to be multiplayer. It also means that if you're multiplayer and you're using a client server, I can charge you not as a one-time fee, but I can then look at charging you as a service, right? So I can charge you to say, hey, you are playing this game, I will get you to continue to play this game, and if you want to keep playing this game, you have to keep paying me money. And if it's a single player game, you can disconnect from the internet and just play it, whereas a multiplayer game, you have to be connected, therefore I can check that you're there. So when we have a look at these building communities, we have these ways to create communities. When you are starting building your games, now it's a little bit early for you, but often you will have a community manager involved early in the process. It used to be that there were two people in a game development company, a programmer and an artist/designer. Then we had three people, a business person, a producer, a programmer, and a designer/artist, right? Because you need the business stuff was so important if you're going to make this sustainable, right? Because games became much larger and getting attention was much harder. We then added a community manager. So kind of the minimum team of 4 actually only has 2 content roles and has a business person and a content manager as the additional roles, just to secure funding and to build the community. Now, building your community before your game is finished is actually an important way of connecting out, and building multiplayer means you can have people test your multiplayer game. They can be connecting to you and playing with you and giving you feedback and have it all real time, and that feels more engaging and it feels more alive. So there's ways to to create community, you can allow talking. Now, games were trying to integrate with Discord. Discord went for a phase of saying, okay, we'll build an API and we'll allow you to build Discord into your game using all the Discord features via an API, and people wouldn't know they're in Discord, and you'd just have all those cool Discord features. They weren't really able to make it work, and most games were comfortable having their social collaboration done in a service like Discord or in a semi hands-off community, because it meant you could spin up Discord and start chatting before you played the game, and then invite people to play the game, and then go and play the game, right? So it allows people to communicate, and so you don't have to have that in the game, right? Finding people who are worth talking to. So there's the invite a friend, find a friend, having a way to talk to them, creating some conversation starters. So if you're building a community, one of the things you want to kind of be allowed people to do is some sort of Twitch streaming or sharing achievements. Steam used badges, Xbox and Microsoft added, again, badges and ways to identify yourself in the community as to what kind of game you're playing. And this was to try and share that with other people. So we also look at ways to support friendship building in multiplayer games. So ways to break the ice, friending people, staying friends with guilds and clubhouses. So when you are creating a multiplayer game, it's not just about getting the JPEG to sync with the other JPEG, or my character moving to sync with your character moving. It's also this additional meta system that makes the multiplayer good, right? So when you think about the technology, it's not just the tech, it's the full social technical frame. Some of the nice things that you get is also with network play. If you have cooperative network play, you can create a shared enemy. So there's a conflict at the core of a shared enemy, but the idea is that because we're multiplayer, we're on the same team, and we get that sense of community that we're building. You can build your communities around geography or architecture. So we have some Linux people here, and we have some Windows people. Yay, Linux people, I made you a system. You could have gaming communities built around the Linux architecture and say, hey, this is the game for Linux people. If I was clever, I could have used a flag when I was building that detected whether it was building for Linux or building for Windows, and given a different a few different options for Linux players, for example, right? So there'd be ways to create communities around Linux players. Now, this is using the eNet system in Godot, which is its standard networking system, which has builds for Linux, which is why this works in Linux as well as in Windows and in Apple. So the core system is cross architecture, which is why we can have it connecting Linux machines and Windows machines. But you don't have to allow that. You can have you don't have to have cross-platform play. And you'll notice many games were Windows only, or PlayStation only, or Apple only on iPhones, and those to some extent created sub-communities. This idea of expressing your personality and ideas of conformity, so uniforms, shared symbols. Can I express who I am, but can I also show that I'm part of a team? So at the moment, in the name, you all get your own name in the Wii game that we'll go to and have a look at, that we can have a multiplayer games in, but there are other ways that you would allow people to customize their local avatar, for example. Now, interestingly, you can either customize and let other people see the avatar you've customized to, or make all of the other players just generic players with colours, and you see yourself as special, but everybody else is just a robot. Or you can share some aspects of those customizations. Anytime you let people have drawing capabilities, then network sharing becomes a whole issue around Web 2.0 and what's called TTP, which in the UK is time till penis, which is if you give a 14-year-old boy any creative tool, how long will it take him to draw a penis? Now, this was initially talked of as 14-year-old boys. I've seen some of the aftermath of some of the drinking in Norway on the whiteboards around the university, and it doesn't appear to just 14-year-old boys that draw stuff. But yeah, so you have to be careful once you allow full audio streaming and networking, and also drawing on characters or drawing in game, that you have to have some way that you're going to moderate some of that. So, building community. If you're going to build a community, you're going to have like one way to do this is have a dependence on there being other players. Some games will say you need 4 people for this quest. Others, like Farmville, where you would have to be gifted things. You'd require somebody else who was in the game to give you something so you could progress. Right? So there's this idea of forcing you to engage your friends. Farmville and the Facebook games were doing that partly to try and drive that engagement. People then rebelled against that, saying, "Ooh, that feels really shit to force me to harass my friends to give me stuff so that I can keep progressing." And so we wound back from that. But there's still that feeling of, hey, can we make some challenges, can we make some things a large enough number of people so you're going to have to bring in other people? And, can we do an anonymous multiplayer, or should we be doing community-focused multiplayer? So when you're looking at community sport, you're looking at fostering small groups. You're looking at what are your obligations to other humans, and you can create events in your multiplayer games around game jams or Friday nights events. Friday afternoons, sometimes those are good times to set up games. You can still do LAN parties, right? And they can still be a lot of fun. And there's pizza evening and gaming events. You can create events around your game activities. One of the standard things now is also if you can find a streamer who will play your game. Unfortunately, like five years ago, streamers would play your game because it was fun. Now most of them have companies that they are part of, and they will look to be paid for playing your game on stream. Right? So it's now a transactional challenge rather than just is the game good. That of course leads us to these issues of griefing. There's 2 approaches. You can either try and police your community by having strong moderation. Partly your mods on Discord will do that, or remove the opportunity to grief. So if you are looking at within the game, you can remove PvP in areas which are non-PvP areas, right? So you create a landing zone where people can't hurt anyone else in the game, right? And maybe you have specific zones that allow PvP, right? You can disallow stealing. When I drop loot, I can say, well, no one else can pick it up until I've been able to go back and collect my loot. Or I have a loot timer on my drop, and so for the first 3 hours, I'm the only person who can pick it up. So you try and shape the universe such that you minimize some of those negative interpersonal connections. And remember, you don't have to follow the rules of physics. You don't have to follow any rules of reality or the law or anything like that. You are shaping your game, and you are shaping the world, and so you can set up tools to manage and prevent certain types of play happening. You have to be careful. There will be some people who try and work around you. They'll do packet sniffing. They'll do all sorts of things to try and and beat your game, beat other people in the game, get an edge on them. There are, even if we think it, physical barriers, right? So some people will use blocking to annoy other players. One of the things you can do in your game is you can just, if someone's in a doorway, you can just pass through them, right? You could have blocking everywhere else, but then, every time you're in some sort of doorway area, we allow pass through. You could have a constant press. If you're pressing against something for more than 10 seconds, then you pass through it, for example, if it's another player, right? So there's this idea that you can have bumping into each other, but if someone seems to be blocking you, you can move through them, right? So there's adding in additional steps. And this also, one of the things you see game designers tend, or game developers tend not to do, is necessarily use timers as much as they should. They tend to think of, oh, we need to create the interaction right now, and the interaction will be like this. They don't do the, okay, let's add a frustration timer, or let's add an AI timeout, which is a 10-second timer. And so I will initiate a paused 10-second timer, and then in 10 seconds, if this is still happening, then I'll change what's going on, right? So there's this idea of using the tool, using time as an interesting manager of events. In multiplayer scenarios, we also have these ideas of Nash equilibriums and game theory, and understanding multiplayer interactions. The prisoner's dilemma. Do you guys all know the prisoner's dilemma? Oh, we've got someone typing. If you've got any questions, pop them in the chat as we go. Good. Someone knows the prisoner's dilemma. So you can actually have a 3-option style prisoner's dilemma, which is so prisoner's dilemmas present this kind of win-lose. The best collaborative option, as you see in the strategies here, you might see that 10-10 is the best collaborative option. So this is not just a standard option A, option B. This is a 3-option situation. And the reason why we have a 3-option situation is because it creates a more interesting payoff scenario. So if you look for player B, right? So if we're in option C, then either of us, right, we'll both be better off whether we were in option A or option B. We'd both be better off than the 10-10 that we sit in when we're in option C. But when you cycle through, you end up saying, well, if I change my strategy, I'm going to be worse off, right? So if you're pulling option C and I'm in option A or B, I'm worse off. So when you do C, my best option is to do C, right? And the same for player 2. When player 1 is option C, he gets 10 and player 2 gets 5. Player 1 gets 15 if you play option 2, but player 2 only gets 5. So what happens is, once we're in option C and I'm staying in option C, then that is a bad option. It's not the worst option, right? You can see an A and a C is the worst option, is worse, and actually A and A is the absolute worst. But there's an option A and option B where we're both better off, right? We're both doing well. Now, I'm in option A. If you're doing B, and I look at this and go, yeah, no, if I know you're in B, I'm going to go in option A. I know for me it'd be better if I was in option B, but locally I can see that if I know that you're doing B, my best option as player 1 here is to pick option A rather than both go option B where we get nothing at all. Right? Now, creating these unusual relationships means that if you're doing networking play and you have multiple players, you have to understand when you start getting into these unusual payoff game theory situations. And game theory is about understanding how multiple player games work. Right? So zero-sum games, you have the winners losers. A Nash equilibrium is that for a scenario, both players will stay in the scenario they're in because it is the best of their options, given that the other player is going to continue doing the strategies they're currently doing, right? So there is not a logical change, right? Which is why they're the local decisions. Dominant strategies, it is the best strategy for a scenario. There are some flying games where hiding in the corner was the best option. We often talk about bounded rationality. When you're looking at your multiplayers, gamers, they don't know everything, so they're bounded, and they can only reason about the things they know about. And some of them might not be rational agents, right? They might be being emotional. So not always can you analyze what's going to happen in your game scenario, and you'll have to work out how they are reasoning with uncertainty. Now, if we look at some of the practical stuff, right? So that's a big overview. I was going to jump into some more sort of practical details. And most of you have done some networking courses. Have you done some networking courses? Do I have any comments in Discord? Yes, we have. See, what I could have done is I could have added buttons in here for you to press that would be voting buttons. But I hadn't got around to creating buttons in my game. But, you know, it's a game, so we could revisit this game, and we can show how you'd add buttons to a game by adding buttons to this game, and then you guys can play the next lecture with voting buttons built into the Godot game, right? And I could start adding things to my lecture game over the weeks, showing you how to do stuff in code. But so let's get into some practical side of things. Right, so I see that we've got 3 yeses and no nos. So I'm going to skim past through this stuff pretty damn fast, just so you're aware of it. So sockets, packets, headers, internet protocol, right? Protocols for finding where a machine is. Protocols, which is descriptions of interactions between systems. Firewalls, which usually block ports or block ranges of IP addresses or block some part of the access to your network. And NAT, which is your network address translation, which is a rerouting system. So when you go low-level networking, you have to understand to be able to talk about all of these things, right? Because otherwise you won't be able to follow kind of what's happening in the system. You might have been shown the OSI model for networking. Have any of you seen this kind of multiple layer system? Basically, it says there are 7 layers. There are actually 5. Nothing implements the data link layer, and nothing implements the presentation layer. It's basically physical, network, transport, session, and application layers. That's it. The other ones were theoretically possible, but no one actually made them. So applications just go straight on top of sessions, and the network was just built on top of the physical layer. Yes, many years ago. But the idea is that you can think of networking happening at these different layers all the way down to a physical system. When we look at a packet structure, when you give data, when you're going to send data, you generally put that data within a UDP header, which then has an IP header, so TCP IP built on top of it, and then you have a link where you've got the frame header and the frame footer, and so you have the data being embedded in a much, much larger piece of information. UDP, Universal Data Packets, Data Protocol, is a source and destination. It just tells you where it's going. So when you have a look at IP headers, basically you have this idea of there being a source IP address and a destination IP address, and this basically just tells packets how to get from where they are to where they're going. When you add a full IP header, it also has some checksum information, the identification, total length, some options and some paddings are all in the header, and then you go to a full, so that's an IP header with source and destination, and it has that additional information. And as you can see, it is this 0 to 31 means that it is 4 bytes by 1, 2, 3, 4, 5, 6. So it's 4 by 6. So it's 4 bytes by 6. So it's 24 bytes of data. Right? So not very much. But that 24 bytes of data, when we start looking at a full source and destination port and we start using IPv6, we need much larger port, and we need much larger IP addresses, and we need larger checksums, and we also have additional information like the sequence number, acknowledgements being set, window sizes, checksums, and a bunch of options. So our header becomes 160 bits. So yeah, so these become we start up to option 20 bytes, the octet, and then it becomes much larger as we add more information. Right, so yeah, there are lots of formats for adding libraries, adding information. Doing your own networking is probably not the best idea, right? If you really love low-level networking, then great, go for it because you would love it. But most of the time, you'd be reinventing the wheel. We highly encourage reuse. We highly encourage using Godot's eNet system, using Unity's networking system, using Steam's networking system. Building your own leads to potentially many very hard to find bugs and network attacks on your game and instability. So we encourage you to use tools. Right? So find the best tool for the job, use it, benefit from the tools, and it's already been tested. So often when you're using a tool, one of the first things it will do, it will offer you a default text messaging system where you can send strings from one machine to another, often with TCP, right? So it guaranteed the whole string gets there. What some people do is they go, oh, well, that's easy. What I'll do is I will create strings that send my information. And so what I'll do is I'll create the string player.x equals 57, which means the player is in X position 57. But to send that, they have to send the letter P, which is a byte, the letter L, the letter A, the letter Y, the letter E, the letter R, the letter dot, the letter X, the symbol equals, and then the number, which could be a symbol 5, a symbol 6, right? So they're sending huge amounts of data because they're sending a string that describes the data rather than sending a data that's packaged as the first number you'll receive will be the X location, the next number you receive will be the Y location, the next number you receive will be the hit points for the player, the next number you receive after the next byte, next 2 bytes, the next 3 bytes will be player 2's health, the next 2 bytes will be player 2's position, the next 2 bytes will be player 2's Y location. So what happens is if you're doing network properly, you actually compress the information. And so a lot of these tools, they will talk about adding objects to the list of networked objects, and you then decide how often you want them updated, what kind of updating you do, but you don't write the code that says, oh, I'm sending this in this way, because the tool works out that optimization. So yes, messaging, sending strings, very often used by middleware tools, easy to customize, really bad for games. And if you're going on long distances, you need optimization. They'll often use JSON or XML, and you know XML and JSON can also be very verbose and pad up data, and so you're sending quite a lot of text data back and forth, where you could if you're using packet compression, send something very small. So you actually want game optimized multiplayer packaging system, networking systems, so that they focus on compressing the data. Now, one of the things you'll have to understand is the messaging queue. So you put messages in, you have messages come out, and being able to pack and into a queue and pop out of a queue, very useful. In UDP, that's basically how we move from UDP to TCP, is we add error correcting queue to data. Okay, so when we're doing game updates, you need to tell the other player, you need to, when you're thinking about your game and your networked game, are you running synchronously, where all players are having a local synchronization, a local simulation? If all states are deterministic and you have everybody is running the local simulation, do you synchronously pause everybody when any one of the players is running slower? Right? So do you run at the frame rate of the slowest player? If somebody hangs, does everybody pause, waiting for them to get back online, and then you can continue? This is clearly a bad idea. So you're going to have some level of asynchronous. It's going to be mostly synchronous. You want it to be happening at mostly the same time. But anytime you've got a server outside the room you're in or down the street, you probably will have lag happening, and you'll have to manage what it means to be asynchronous, right? So the updates will happen at some point, and you might get ahead of the server. And this is why some of the networking is so hard, because you have to handle multi-threading, you have to handle asynchronous updates, you have to deal with updates coming in out of order potentially, you have to have conflicts between when I say I've shot something and you think you've been shot, or I try and pick up an object and you try and pick up an object, and those objects were still both available in our game when we went to pick them up, but you got there technically first, even though I look like in my game that I got there first, and so we have to resolve ownership contradiction between games. So there's a lot of these kind of state information that you have to handle. One of the interesting ways of handling some of this, so you would have seen games where when I get a network update, the player flicks to the new location where they're supposed to be, and so you get this kind of flicking behavior. There's also another way that they do this, where they do a predicting behavior. So what happens is, if I thought you were heading up here in that green route on the high layer, and in fact you'd changed direction and you were heading in the red on the low lane, then I get, after 4 frames, I get information, oh, actually they were heading along the red route the whole time. Either I can flick you over to the red location, and then I get this popping as people move around suddenly, or I can look into the future and go, okay, I'm going to predict where you're going to be in 4 frames, and I will just bend your current location and make you bend over time to that new location, right? So there's this idea of yes, we're out of sync, but I'm going to bend you back into sync, and I'm going to bend you, maybe you're moving faster than you would normally be able to move, but if I do it over 4 frames, the players probably won't notice that on my version of the game you're being bent to try and line up with where you are actually on the server, right? So there's this kind of delayed bending of alignment between the local version and the network version. Is it possible to have a little break? Yes, we're at 10 past 10. I should let you guys all have a break. There are not too many more. Okay, there are too many more slides. So what we'll do is we'll have a 10-minute break, and then we'll come back and we'll finish the lecture, and then we'll have a wee play in the multiplayer game, and we'll talk about how it works. So we'll do a 10-minute break till 20 past. Right, so excellent. Joachim, you're saying, should we have started on the code yet? What should we have started on, done at this point? Yes, you need to have decided what game engine you're going to use. Remember in the first week I told you try out some game engines. You need to have decided what game engine, you need to have started working on your game design, and yes, you could start coding now. It's okay if you haven't started coding, so long as you've been thinking about your game, you've been developing your game, you've been thinking about what is going to be in the game, you've looked at some of the game design documents that we put in there, and you've started thinking about the game. You should be moving towards coding, having selected an engine, and you should start allocating different parts of the game for different people to start building. Some of you may have already started building the game already and be quite a long way on. But we'll take a break and let you guys all wander off and get a coffee, and I'll be back shortly. Yep. Should we focus on making a game demo or more a level 1 type thing? You should start by understanding what is fun in your game. And so try and create that minimal game loop, right? So what does the player do? How do they move around? How do they interact with the world? How is that interaction going to be fun? Can we start testing that, right? So yes, get some assets into your game, but you should also build a menu, build an end game, build a restart so you can replay. So build the kind of quality of life stuff around the front and back. Like this game here, that start screen where it goes to it says host, play, or game. Having that splash screen is a useful thing to do. So one of you should be thinking about that overall framing, and someone should be thinking about what happens in the core of the game. Because eventually you'll be having to make a whole game. Not just a level 1 or a demo, but actually a whole game. Okay, I'll go and get myself a drink. Okay, so we're in just chatting mode at the moment. And yeah, so there are some really nice, Godot engine has some really good tutorials. So absolutely start going through those tutorials. And you'll see that in that very first lecture I said, hey, go and try this tutorial. And that's the important bit, is that you are working and starting to play with how to make a game. So just as an aside, while people are away, I'm assuming that the whole Charlie Kirk being killed and it being blamed on games is also affecting Norwegian gaming community, or at least Norwegian political communities. Do people have an opinion on Helldivers 2 and the Eagle bomb, 500 kilogram Eagle bomb, that was noted in as some of the only explicitly kind of motivated? Okay. You haven't heard anything about being blamed on games. Right, that's nice. Yes, because 2 of the 4 bullet casings, so all of them had stuff etched on them. Some were just memes, but one of them was a Catch This Fascist meme connected to Helldivers 2. And Bella Ciao was, which is an anti-fascist song, but also comes from the sort of Groiper community, but also is in Far Cry 6 rather. So um, has also been connected to gaming, and there is a discussion that he was a chronically online and was playing a lot of games. So there is a kind of split politically as to, do we blame this on left-wing radicalization? Do we blame it on gaming communities? Because we can't blame it on guns, because apparently that's not allowed to be. You're not allowed to blame it on gun culture. But you can blame it on games culture, and you can blame it on the left, apparently, even though that doesn't appear to be consistent with the behaviours. But yes. So Bella Ciao is also connected to the Groiper community, and some of the Pepe the Frog, and some of that there is some evidence that he was potentially also into the Groiper movement as well. So and yeah, it's all very strange. Right. Okay. So we've had our 8-minute break. Just me chatting about random game stuff. If we decide to do multiplayer or have a multiplayer campaign in our game, how will we be graded on it? Thinking mostly about how you are just one person. Well, what I would like to do to grade you would be, if you're going to have a multiplayer game, organise a time where I can grade you while you and I are playing the game together. Because A, that makes it the easiest for me to grade you, because I can see the game playing and you can help me play through it. It does become a little bit like an oral exam at that point, but it does mean that I don't miss things. Right? My preference would be, if you would like it to be multiplayer, when I grade you, we set up a grading time, and I grade you while you're playing the game with me. If that makes sense. I mean, if you refuse to play the game with me, then that would make it harder to grade. Okay, so we'll get another minute of just chatting, and then we'll go back to talking about networking. And eventually we'll play the game, which is just a sample game to show networking and multiplayer. I might grade you more if you beat me, right? Because that that indicates that you're good at the game. So no, I will not grade you down if I lose, or grade you up if you lose. No, I'm more interested in the game itself and the technical aspects, the quality of what you're doing, the smoothness of what you've done, the ability to discuss technical debt, the ability to understand what's going on. Tell me how you would change things. I'm not grading you based on my ability. However, that said, if you make a platforming game and I am unable to jump across the first platform because you've made it pixel perfect, and I have to hit exactly the right pixel to be able to jump and just land perfectly on the next platform, and that is the very first jump, I'll be super critical of you for that. Make it much easier than that. Yep, Godot has a good showcase of games as well. Okay, let's get back to it. So, as I said, Peer-to-peer is a standard way where my machine talks to your machine. With a client server, at the moment, this is the server. I don't have so I am actually running a version of this game as the server. It's not a separate, dedicated application. You can write your server as a separate program that will run up and be a server. You see this with Minecraft servers, right? When you run a Minecraft server, it runs up as a headless server and you don't see the world. To see the world, you have to come in as a client and look at what the server is sharing. I've got this as a playing server where I'm a player and I'm the server. You can also have listening servers and migrating servers where when the server drops out, we can migrate to another server. In fact, technically, that's what I've done here, is because I dropped out with my other server, and so I've taken over. I've said I'm going to host. Now, that's because it's all using my IP address, and so I didn't have IP issues in changing different IPs that you're looking at. If you are going to change the IP address of the host, then you're going to have handover protocols. You're going to have authentication protocols. It becomes harder to do when you do migrating servers. Peer-to-peer discovery, how to find the IP address, this becomes the biggest challenge. So particularly when you are hiding behind a firewall, and even worse, when you have the new networking shuffling IP address protocols. Because we've run out of IP4 addresses, there aren't enough of them in the world. What many service providers, right? So internet service providers are doing is that they'll have a block of, say, 100 IP addresses, and they'll have 500 clients. You as a client are probably not hitting the internet at 100% traffic all the time. And so what they do is use their pool to access the services that their 500 customers want simultaneously, and they just hand them in and out, right? So one IP address will be grabbing this website, and then it'll go grab that website, and then it'll go grab that website, and then it'll go grab that website. And the first person using it, that pull from that website, when they grab the next page from that website, they might have a different IP address, or that IP address has been used 5 other places across the internet in the time that they were waiting for that information to come back. Because I've got so few IP addresses, I'm now using a pooling approach to try and minimize the IP dedication and the downtime, right? So once you're doing that, it's actually really hard. You need to basically have a static endpoint which holds the IP addresses of the people it's connecting. And then you have these, again, layered protocols that manage all of that internet traffic so that it can manage this issue of IPs changing constantly and those sorts of things, right? And that's what the Steam network libraries do, the Unity network libraries, and the eNet stuff needs a static IP, but the idea that you set up one server with that, and it manages the communication between all the clients, right? So peer-to-peer can be quite tricky. What we are doing with this particular game is firewall. My firewall is there to try and present access. I have cut a hole through the firewall and created a port forwarding. You also may have noticed that when you started the game, Windows asked you, would you allow this to access the internet? And when you went OK, it added a rule to your local firewall on your local machine to say, hey, I'm going to let this program access through this port. Right? And so you've got a firewall on your machine and you've got a firewall on your router. And so there's multiple layers of protection. And the networking has to get through all those layers. And that's why don't try and do this yourself. It is possible to do. It just takes a lot of work if you're going to do that all by hand, right? If you set up the initial known server that mediates the initial connection, that makes everything a bunch easier. So with these client-server models, there's a centralized hub of communication. The Unreal 5 uses a client-server for its multi-user games, and the server defines what is true. Interestingly, in the Unreal system, when you are when you're just starting out and you're using the free service, everybody uses the same, I think, rocket ship or rocket star game name, and everybody's on the same game. And what it does is it looks at that, and you all connect to its server, and your games have registered their versions, and it will only let you see other people using the same networking system with the same version of the game. But because there are so many people doing this, it can be quite slow and it can be a bit flaky. If you want a dedicated server, once you pay and you are an uploaded game and you're paying for networking, then you get a dedicated server and everything runs a bit smoother. For Godot, we've got one player, and so we're using the multiplayer API. And yeah, there's a pair create server and port and maximum connection. So that's what I've set up in this lecture. So who owns the world state? If you have a client server, then it's easy, it's the server. And what I mean by world state is that what is the true state of the world? And that's why I had this whole follow host, is I don't follow you, you follow me. I'm the true state of the world, and you are a ghost running around and having a look at other parts of the game. So if we using peer-to-peer, then it is much harder to know who has the true state of the world, right? That has to be negotiated. It might have handovers. You might need to hand over code and while avoiding multiple executions of things. There used to be a Diablo hack, which was a teleport hack, which as you stepped into a teleporter, you would drop an item, and because the scan of your items, right, the copy, was created at the moment you went into the teleport system, and the deleting of that level, the ending of that level happened as you moved to the town. There was a very short 1 or 2 frame gap between when you entered and when you arrived in town. And if you dropped an item just at the right time, it would take a copy of your inventory, you would drop the item, that item would go into the level data would then be read, and it would have that chest of gold in it. That chest of gold now existed in the level. You had deleted it from yourself, but because you'd already done your copy, when you arrived in town, you still had the chest of gold. And when you went back through the teleporter to the level you just come from, there was another chest of gold on the ground, so you could pick that up and double your money, right? So, and that was an issue with the timing of when you handed over control, right? And there are lots of these network challenges and network hacks in games. One of the ways we minimize that is trying to do all the cleaning on the server. And if your client gets out of sync, we just force a resync on your client. So loading data between levels, you have to work out what do you do in this reread period between one level and another level, who owns what as you go through there, who is in charge of running your physics, who's in charge of animating you, who's in charge of interactions with the other parts of the world, who's in charge of your audio, all of these like travel issues. How do you connect multiple parts of the world? When we look at Godot networking and actually at the Unreal Engine, both are using UDP, right? It's a standard UDP underneath. The high-level networking connects basically scene trees. And so what you do is you say, oh, I want these objects to be replicated at the other end. And when there is a multi-layer peer system which is a mid-level networking which exists, but you're not supposed to use. You're supposed to use the high-level networking. There's also the packet level. Again, it's very low level. If you're going to that, it's because you are having massive challenges with trying to get your networking running, and you're probably deep in the code at that point. If you're running locally, easy setup on localhost, or find your IP address in your local network and just run within the local network. That way you can get multiplayer without having to worry about having a server, because you can set up your own on your machine and then access it by the 192.168, and then everything's within your local network, right? So that's the kind of LAN multiplayer, which makes networking much easier. Right? So if you're going to do multiplayer, that's probably the best one to be trying. If we have a look at Godot, when you connect to the server, every player in the game gets an ID. So network pair connected gets an int ID, and network pair connected int ID. And we use these RPCs, these remote function calls, to have effects on all of the clients. And the thing is that I suppose the big mental shift is understanding that as a server, I'm just one of the clients, and I might need to work out to do something slightly different when I'm the client. And so the code checks what ID am I, and if I'm the server ID, I run server code, and if I'm client ID, I run client code. Now, what you've got to worry about is people hacking your executable, flicking themselves to being server mode, and then being able to try and change the world in interesting ways and break the game. So there is a move away from having client servers combined, is that you have just clean clients and you have a server, and they are separate programs, so you can't create your own server and hack it. Now I know there's a whole movement based on not killing games, that the idea that if you have network games, the servers have to remain alive. That's an interesting ethical discussion that's been happening recently. Because servers have cost, it is hard to say once your game is no longer making money, you still have to pay for having it up, or else you go to prison. That seems a pretty harsh thing to do to people. But I think the idea of making your server open source so other people can run their own local versions of the server, that makes sense, right? But the idea of having games where knowing the ID, thinking, okay, I'm coding this, when this remote procedure call comes in, who runs it, in what way, is it me running it locally, is it you instructing me to do it, and setting up that authorization. So when you look at, that's a bit darker than I intended. When you look at the Godot setup, when you load a player and instantiate it, can I make that easier to see? Not really. Okay, that's much darker than I intended. But the idea here is that I can load a player scene. Now in Godot, the player scene is basically the character and some code associated with its scripts and sub objects, and it's all the objects associated with the player. I instantiate that player object, and then I give the player a name, right? And so that can be, in this case, some self-pair ID string, and then I set the multiplayer authority to the self-pair ID, right? So I'm loading myself, and I'm setting the authority to myself, and then in the world, I add child my player, right? And so that means that I get loaded in, and I get my name, and I set myself to be authority over myself, and then I add myself to the world. And then when I load the other players, I go through all of the P's, which are the player infos, right? And I instantiate their character scene, and then I find their player name from a string, from P, which is P in player info. And then I set multiplayer authority to P, so I set their authority to them, and then I add them, right? So I'm going through adding myself, and then I add all the other players. And when I'm running code, I'm having to refer to player IDs and who's in charge of them. And when I get network information, I make sure that that information is coming from the networked peer that has the authority over that multiplayer's object, right? So there's this, you're setting up these player connections. When we look at actor replication in the Unreal networking, we set up explicit types of replication because you don't want to replicate everything. So with actor replication, we usually set up movement replication. So when I move, the character on your end moves. If an authoritative actor has replicate movement enabled, or B replicate movement is set to true in C++, it will automatically replicate its location, rotation, and velocity. So the idea is if you're using Unreal Networking and you tick the box of replicate movement next to an actor, or in C++ you set the boolean which is replicate to true, then the networking service will take the location, rotation, and velocity of that objects and replicate that across the networked game. It won't update the skeleton mesh and the static mesh components. So the animations, it won't try and synchronize the animations. It won't try and synchronize the materials. It won't try and synchronize particle systems. If you have puffs of smoke coming up, it isn't going to say, oh, I'm going to try and synchronize the particle emitter so the particles on my side look like the particles on your side. No. It will start a completely different particle server, and when you run on the ground, it'll just spin up a particle server entirely locally and ignore whether or not the particle server is working at the other end, right? It's not replicating, it is just running locally, right? It won't necessarily replicate sound emitters. It won't replicate other physical objects. You've got to explicitly tell it what you want to copy between the games. And there are lots of settings. So there's dormancy, right? So what happens with an active agent? There is data-driven network update frequency. So you can decide how frequently you update based on how frequently things are changing, and you can manage your update rates per second. And you might decide that for actors, they update 10 times a second. For AIs, they update 5 times a second. And for everything else going on in the game, it only updates 2 times a second. And so you manage the network frequency by the amount of data you're expecting and how frequently you need to update this information. There's also adaptive network frequency updates, so where you dynamically adapt the update if it's meaningful, right? So the idea is that you have this net update frequency get set as the maximum possible rate you can be updating, and then you have a minimum net update frequency, which is minimum 10s, and basically it adapts to decrease the network load while it doesn't seem that there are interesting things happening, right? So and while there aren't things near you, it will go, oh, well, there's no one around me, and the server doesn't think there's anyone around me, so I'm just not going to update the network very frequently because no one else cares because no one else can see me, right? So it's this having the game manage the amount of traffic. Lots of good resources, lots of links to look at in the from Unreal. Setting up the located servers, actor replication, character movement components. Go and read those. They're good documentation. They've got some good tutorials. Couple of things we can look at for optimization. So one type of optimization is quantization. So instead of having the very, very finest floating point 32-bit integers, you compress it down to 16-bit floating point, and therefore it gets much smaller, and you can quantize your data send a smaller amount of data between you and the client. Yes, things get a wee bit jerky and a wee bit bumpy, but then at the other end you can try and smooth those out. And the idea of if you're only interested is, did the bullet hit me, then pixel perfect might not be what you care about. It's just near enough is good enough. If it gets within 5 pixels of you, we're gonna blow you up anyway. So I can quantize it, just check, is it close enough? It's close enough, and manage not with full resolution, but that minimized, broken up into 5-unit blocks. Unity introduced a new networking system, netcode, where you explicitly define a bunch of the networking data. Again, I am not sure about Unity's networking, but it is actually there. If you want to understand it, again, it follows these principles of how often do you update, what exactly do you want to update, what parts of the player do you want to update, how frequently do you want to update them, what other objects need to have to be replicated to the other players. You have to set up spawn points for people so that players don't all spawn in the same place. So there's lots of these sorts of setup in Unity networking. Okay, so with 10 minutes to go, I can go back to game. Now, in the back to game, some of you who have pressed back to game, and you can see there's 2 lecture. Now we have choose a network type. I've not been playing at all with the Steam networking. I haven't registered this with Steam, so I don't think the Steam networking is working. I haven't actually tested it. But I do know the eNet is working. And what we do for that is I will go and grab the my IP again, and actually I suppose I should really use IP config, but that's okay. So what I want you to do is I will copy that and I will put that address into the Discord chat, and you can ask me questions about networking. And so that is the gaming, and I'm going to put in that and go :7000 because that is the port number that I've set up, right? So the idea is you then have to go :7000 on the back end of that. And if I hit host, let's see if this will work. Oh, where's my mouse? There it is. And I hit host. And it says Simon because Simon's my username. Now, you should be able to put that IP address and port 7000 in and be able to get a, and when you go, so what you should be doing is, and if I can get this to work, why can I not move? Okay, so if I go eNet and I go join, and so I paste that in and go :7000 and go join. Aha! Interesting. There, Sarah, you've joined me. So, and we can, oh, yep, there's another another person has joined. So, haha. And I think, if you press H, you might, I think H might have the hello added to it. I don't know if I added, because I started talking about how oh, you're blocking me, I can't get up there now. But here you can see each of us has the name. the name is the username that you're logged in on your machine, because you can. That's it. Well, hey, someone gave me an extra boost. By well, hey, there's collisions going on. So as you can see. Right. I think it's interacting with Steam. For me, it says Space Wars, the default API. Right. So yes. So that is the Space Wars is the default Steam API, and so that's the default multiplayer. And we've got a Magnus there who's just joined. Now, as you can see, there's woohoo! If you get your timing right and jump on top of someone's head while they're jumping, they'll give you a super boost. So yes, that's how you do the. If you get your jumping on people's heads right. So I'll see if I can. So yes, very very strange jumping movement. But as you can see, a simple platforming game, again built entirely in Godot. So this game, this bit of the game, this is the default for the multiplayer, the easy multiplayer, which is woohoo. That's why some people got. So if you go to easy peasy multiplayer, and I'm going to upload all this code, it came with this platforming code. What's nice about it is that it. So I just did the lecturing bit, right? So I did the how do I make this into a lecture so that I can do lecturing and add the screen so I can choose between the game and lecturing. So what happens in here is if you're watching my screen, which most of you aren't now because you're playing the game, but if you have a look at the main scenes, you've got, oh, those are all the slides. The main scene is this is the game here. What you can also see is if I go to the tile map editor, so Godot allows you to have these tile maps and then set up the tile map and place those different tiles in different locations. So for example, if I zoom in here, you can see I've just accidentally replaced part of that slide with a different tile. So I would want it to be, where's my the diagonals are base tiles. Oh, I've got a, I see other people joining. So it's probably that tile is, oh no, that's a different angle. So I'd have to find the right tile of all the tiles to be a tile that goes from there to halfway. So I can't find that tile because it's not that one. But yeah, so the idea here is that you would set up the different tiles, and the sprite sheet has all of the potential tiles that you can use. It's that one. There we go. And also it sets up things like collision detection. So all of this level was done in the level editor in this tile, on this tile layer, and all of these objects are different objects that are coming from these from this tile map, and so they're just being placed as a tile. And then it has the collision layers put over it. So if we have a look, you've got the player spawn position, there's some parallax in the background, and a whole bunch of player position information. And this is the networking UI. So the networking UI has, if we turn that off, you can see it's this bit here. So that is all part of the networking UI, and that's its own scene that you can open the editor, and you can see here it's just got the enet and the Steam, and those are buttons, and then it adds additional text on top of that. So the multiplayer and all of that code is freely available. I'll be uploading it with my changes to the Yurvik system. But if you want to have a look at easy peasy Godot networking, then you can find the base code which has all of this. And it's a nice way of having a look at how a tile map works. If I go back to the main screen and I go and have a look at the tile set, you can see here, it's a little bit hard to see because it's so tight, but if we have a look at the setup, do we have the tile source? And I'm just looking for where I go. Where is it? So if I go to the main scene, it is under the tile map layer. And I'm just looking for the physics mode interpret. There is a physics painting. I'll have to remember how to do that. But yeah, so we can do a tutorial on how you create the collidable areas by pulling over polygons over these. So those are all the grass ones. Those are dirt ones. There should be, and I thought it was under painting layers. The way of interacting with each of these and painting over the collisions so that you slide down them. But you can see how you can make the tile map just by selecting objects here and then placing them in the world. Okay. Where did I find all the sprite sheets? The sprite sheets came with this particular easy peasy one. If you want to find sprite sheets, I find, well, there's so many players and they're all over the place and everybody's standing on my head. Right, you can see actually they're intentionally standing on my head and I can't get off. Haha, woo! So if I go to networking, if I bring this up and I go itch.io, you can see that there are, if you go to game assets on itch.io and you look for sprites, you can have a whole bunch of different ones, but there are ones that are discounted that you can pay for or ones that are free. How does patterns work? I was unable to make any pattern when I was playing around with the tile map. So, how did patterns work? Oh, you mean how does the collisions, painting on collisions? I have done it before, but I was just struggling to find because yeah, you've got to get the right parts of the layers, and it should be what's these? No, that is grid visibility, highlight layer, select all layers. No. Where are we? It is in the, I think it's the tile set has the paint and select property, which is physics layer 0. That's where it is. Okay, so when you're in paint, right? So what we're seeing here is, and if I scroll down to something, yeah, that's a better one. So if I scroll into that, what we've got here is that I can create an area that is the collidable area. So now this area is collidable. If I went like that, then the collidable area would make me come off the surface and come down, right? So I would slide above the surface, and so you can see here I've got, this is actually supposed to be up here and here and in here, right? And then I click that as the painted area. So if I go and look, you can change the texture origins of these. You can look at you can modulate the depth index. You can play around with how to sort them and why. So there's lots of things you can play. The physics is how you deal with those collisions. So if I was looking at something that had a more interesting collision box, so let's see, what do we got here? What can I show? Let's pick one of these slidey ones, right? And just go, hey, you're a slidey thing, but I'm going to change my collisions so that I'm going to have that pop out in an unusual way, right? So it's gonna change that. Now, if I save that and I click on that to make that paint go over that shape, and it missing out, actually I'll add another point there and drag it down. So now I have a bump on those. If I save that, and I think, well, yes, it will require me to leave the game. But what that would do is it would mean that these edges become more bumpy because my collision would take me off the surface, right? So that's painting the physics layer collision onto the tile map. Okay, well, it's 10 o'clock here, so I think what we need to do is, I see all of you people have jumped on and been bouncing around. Yes, using tile maps. Saving and loading pre-made tile placement using patterns. Yep, that's the one. Okay, so I'm going to leave the lecture. Okay, and leave that one. And if I play that, and I go to multiplayer game, now I probably killed that that for you. Oh yes, you can see now. Hopefully you can see how when I slide down, I slide out from the surface and then down and slide out from the surface and down, because what they've done is the left and right, they've just, and I get stuck now trying to go up because it's too steep. But you can see that if I land, I'm now walking up and out over the top of things, right? So you can see I'm hovering over the edge and then I slip down, right? And I'm hitting the edge of those now. So I've got the very bad block approach to the collision on those surfaces, right? So this is now a very bad approach. Okay, right, so the task for you all now is to break into your groups, jump into your individual voice channels, and meet and talk about your games and make sure that you're making progress. Okay. Now, Napuna is there on Fridays to check up on you and see that you are making your games, but I'm going to say good night to everybody and good luck. Hopefully that whole playing the game of a lecture was an interesting approach to talking about networking. I will share the Easy Peasy Networking, you'll be able to find it, but I'll share that code once I've got my logins correct, and you'll be able to see that code in the IMT 3603 area, and I'll save and upload the previous lectures recordings that I've been doing, because I still have them on the screen, I just need to upload them. Okay, so I'm going to stop streaming. I'm going to